everyone. This is me, Hayman Aziz. This video is the second part of my first video in which I had it a few weeks ago. The first video was mainly very general, but this video is mainly concentrating on one shape, which is circle. And then we will explore a number of interesting methodologies and formula. For instance, here now, if you look at it here, this is a two-dimensional case. And this two-dimensional case here is if you have got, let us say, a closed loop. But obviously here, a closed loop, if you deal with it like any curve mathematically, the problem is highly complicated here. But the idea simply is, if for example you have got a closed loop, so what is the maximum number of people in which you can accommodate within this place here so that you do not violate the social distancing rules or guidance here. Before we start, it may be a good idea, particularly for a circle, we have got just some few pictures. For instance now, if I have got a circle in which the diameter is less than the social distancing, like for instance here, this is the social distancing, which is d, and then assume that I have got a circle, and this circle here, if you look at it, the diameter is less than that. And then obviously here there is only one person that can be accommodated. So it means you can't put definitely more than one. And this is quite trivial, which is easy. Now the second is if you have got a circle in which the diameter is equal to. In the case of the diameter equal to, then there is only possibility of two persons in which you can put. So for example, one person can be just residing or standing by the wall, and then the other one is standing by the wall. Exactly, they are on opposite to each other on the diameter. And those two are exactly the same. It doesn't matter. It means you just do the orientation. So you can't have more than two. The third possibility, in which this is the interesting one, we deepen a bit more. If we have got a diameter which is greater than, like this is a circle, and the diameter of this circle is greater than the social distancing d, then definitely here one has to be realistic. It depends on how much this diameter is greater than. For example, maybe you have got a possibility in which you can have only two. And then maybe you can reach to a stage in which you can have like this case here, in which 1, 2, 3, 4, 5, 6, 7. Then the aim of this video here is to introduce a methodology here, whatever the diameter is, related to the distance learning, how we can find out the maximum number of people in which we can accommodate within this circular shape, like for instance here, a circular hole. We start from here. So now assume that, for example, here now you have got a circle. This is like the circumference of a hole. And then now we introduce a method how to find, for example, here the maximum number of people in which we can accommodate in this area. What we do, step one, then assume that we have got those circles in which they are exactly tangential mathematically to each other. And then obviously this distance between their center is d, and this is d as well. Then it means if I introduce that the angle is theta 1, this is theta 1, the one reference to the first circle. Because later on we have got theta 2 in which of the second circle and so on. In this case, certainly r is going to be greater than half d, or certainly here the diameter of the circle is greater than the distance learning if we multiply by 2. Because the other cases we have dealt with, there is no point for me to repeat it. And this is a very basic fact of trigonometry. I'm quite positive most of people are familiar with this fact. D squared is equal to R squared. R is this, and R squared minus 2R times R times cosine of the angle. And then the angle can be found through the cosine inverse by this little formula. Then later on, we know the fact that the whole angle around the circle is 360, if this angle is in degree. Then simply here n1 means the number of people in which we can accommodate exactly on the circumference is the greatest integer which is smaller than this figure. Then it means you need to work out this figure. And then if for example, let us say numerically this figure comes out to be equal to 25.2, then it means the greatest integer here which is smaller than that, then this is 25. Then even if this is equal to 25.99, still it is 25 because we are not rounding it. Step number 2, now we focus on the second circle. The second circle means if this is the R, which is the original one, definitely here this distance to here is going to be equal to D, because this is half D and this is half D, and then this is equal to D. Then it means exactly the same method as you had for step 1, but this time the radius is R minus D. Then again, this is the numerical calculation. We can find N2. Okay, and this is N2, by the way. Here maybe there is a little mistake. Then N2 can be found. This is a simple example, like assume that you have got a spherical or maybe a circular hole of radius 10 meters here, and then we are now deploying exactly the method in which we introduce, and then we identify how many number of people we can accommodate here to maximum so that the social distancing is not violated. This is circle 1. Certainly in my case here radius is equal to 10. 10 is greater than half of 2, so I just assume for simplicity the current situation, which is 2 meters, but this method in which I introduce it can be applied to any social distancing here. This is just a simple numerical example. Then now theta 1 can be calculated, which is 11.49 degrees here. Then n1, if you calculated 360 divided by this, which is 31, is the maximum. So it means maximum number of people you can accommodate on the outer circle is 31. Now circle number 2 simply here is R minus D. Exactly, we use the same formula but for a different value of R. Then this comes out to be 25. This is circle number 3, then the same way. So I strongly advise, if you are interested in the methodology here, if you repeat those calculations for yourself just to train to understand the way in which it's done, and then rework out maybe even for different values of R. And this is circle number 4, in which is 12. Okay. Then finally here this is circle 5, but in this circle 5 you reach to a conclusion that this is 6, and then obviously this is quite clear. Then it means the last radius left will be equal to exactly half of D. Then it means there will be 1 in which can be accommodated at the center of the hole, this circular hole. Then if you add all of those numbers, then this will be the total number in which you can accommodate it in that example we have given. This is a simple animation in which demonstrating how the same steps or the same methodology in which I did through an automated one, and all the people through the example can be accommodated. So I strongly suggest if you can watch it a bit more closely. This is now the completion of circle 1. This is exactly circle 2. Can you now notice that this distance from here to here is exactly equal to d? And then do not forget there may be possibility of a circle in which not necessarily all this other circles here they will have to touch. There may be a space, but that space is not going to be enough for accommodating one person because you can violate or the rule will be violated. And finally this. What I did here, particularly for those people who are interested in programming, this is a simple algorithmic way in which you can write this algorithm here. I have done it myself through Python, through Visual Basic here. I strongly advise you can just apply this method here in which I did it through the programming language in which you are interested in. But there are a few points in which you need to observe from this algorithm here. As I'm quite positive those people who are familiar with programming here, they know the fact this is pseudocode, is not subject to any syntaxes here. Then you need to adapt it to the syntax of the language in which you use. Then another point here, most or all programming languages, normally whenever you deal with angles, particularly for the inverse case here, they use radian. So be aware of that fact here. And that's why in this step here, the radian will be converted back into degrees. Okay, or maybe you can just keep it in radian and 360 you can use 2 pi. And then you need to check particularly here the inverse of cosine because different programming languages may use different methods or maybe different syntaxes for the inverse of cosine here of angle. I hope that you have enjoyed the video here, but it may be a good idea, particularly if you are interested in applying it, just test it numerically by yourself and then use the same method in which I had maybe for different values. And then thanks for watching.